The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. My name is Sherry Lynn Phelps, and I am the Agronomy Manager with Saskatchewan Pulse Growers, and I'll be moderating the webinar today. We also have Andrea Laudar, who is our Communication Manager, who is also helping with organizing and all the back-end work when it comes to operating a webinar. We both welcome you to our third Pulse webinar for 2020, and it's good to see so many people taking advantage of this webinar in a time when social distancing is key. I think we're going to break some records for ourselves, and that's always a good thing. I hope this webinar finds you and your loved ones well, and that you are ready for about an hour of great information. A bit on administration before we get started. To get CCA credits for today's webinar, you must be watching it live. Andrea will send out an email after the webinar requesting CCA numbers. If more than one person is watching from one computer, you will need someone to verify those in attendance and include all CCA numbers. The webinar will be recorded and posted to our website for future viewing for those unable to attend or for those who want another look at what was addressed, and that will be on the saskpulse.com website. For today's webinar, all participants will be muted. We will be happy to take questions at any time during the presentation. To ask a question, I ask that you please type it into the question box located in the GoToWebinar dashboard. For today's webinar, we will hold all questions to the end of the presentation where they will be addressed. Today's speaker is Clark Brenzil. He is the Provincial Specialist Weed Control with Saskatchewan Agriculture out of Regina. He provides information and recommendations on weed control to producers, agronomists, government departments and agencies, as well as municipalities. Clark has experience in weed management with the crop protection industry, university research, and government. He has been with Saskatchewan Agriculture in this position since 1998, or over 2 decades now. As part of this role, he also administers the Weed Control Act, raising awareness about invasive weeds and assisting municipalities and landowners in understanding their respective roles and responsibilities under the Act. Today, he will be speaking on weed control in pulses specifically, with a special focus on herbicide layering as well as herbicide carryover concerns for 2020. I will now turn the presentation over to Clark.
Thank you, Sherry Lynn, and welcome everyone. It's good on a windy day to be inside listening to some information. As Sherry Lynn said, there's kind of a 2-topic presentation here today. First, we'll be talking about soil-applied herbicides, and then we'll be talking about herbicide residues in the soil in a general sense, and that could be from either soil-applied herbicides or from foliar herbicides that happen to have a soil residue as well. So to kick things off, I'll try and get my thing moving here. What happened? Okay, we'll do it this way. Not going. There we go. Okay, we'll talk about soil-applied herbicides first. And there's a couple of reasons that we would want to use soil-applied herbicides, and the obvious one is that we would get more choices in herbicide options for our crops, especially pulse crops that have some limitations that way. And the other 2 reasons is that we are always looking at ways to manage herbicide resistance. And when I say manage, I mean prevent herbicide resistance. Once you've got herbicide resistance and you're traveling down that road where you're losing more and more options for particular weed problems, it's very difficult to go back, and you start narrowing your options pretty dramatically. And with pulses, where they have limited options to begin with, if you start eliminating some of those options, then you can be in real trouble. But the other benefit that we get from soil-applied herbicides is actually improved returns, and we'll get to that as we go through the presentation. So from a herbicide resistance perspective, essentially herbicide resistance is all a numbers game. And essentially it's whatever mutation rate in the natural population that we have to a particular herbicide will dictate how fast it increases in the field and how easy it is to keep at a low level and manage effectively. If we use the example here of 1 plant in a million, which would be consistent with group 1 herbicides, we'll look at the progression of that. And if for reference, group 2 herbicides are 1 in 100,000, so you shorten this pathway a little bit. For group 4 and glyphosate, you're looking at 1 in 100 million, so you've lengthened that pathway a little bit. And then for all the other groups, you're looking about 1 in 10 million odds of finding a resistant plant. So essentially, if we take that 1 in a million here and we look at the percent of resistant individuals in that population, that little number through the center there is essentially what you've got. And so when you start making applications and you start getting rid of susceptible types, and what you'll do is increase the proportion of resistant biotypes in that population. And that's why that number starts to get bigger as we go through our applications of that particular herbicide group. So initially what we'll find is for the first few applications that we don't see any problems with weed control. We get very, very good to excellent weed control and no problems. And anything that does poke up above the population or the canopy of the crop, you're looking at, well, that was maybe came after or whatever. Then at one point, you'll see just the start of a patch begin to congeal, and it'll raise some suspicions, and sometimes it's easy to write those things off, but that's your initial warning flag, and you want to kind of pay attention to that, because the next go around through the field, you're looking at pretty significant populations, and it increases very, very quickly. So that curve moves very quickly, much like the curves that we're looking at right now with coronavirus. And 1 in a million may sound like a very big number, or a very small number, as the case may be. But if we look at a fairly modest population of a particular weed at 40 plants per square meter, you could have potentially 24 million plants per quarter section on that farm. And so that means a potential for 24 resistant plants within that quarter section. If we raise that up to a fairly high weed control population within the field, you could be looking at upwards of 250 plants per quarter section that could be resistant to your herbicide. So that's not a small number, and so that means that that'll move very quickly. And that's one of the reasons why soil active herbicides are actually quite helpful, is that by using those in conjunction with your in-crop herbicide, you reduce that number from that very high plant population and bring that population number down very early in the process. And then your foliar product comes along and cleans up the stragglers, whether those be ones that are potentially resistant to that soil active application, or whether it's reducing the numbers that are available to build resistance to your foliar application. You're accomplishing both in the same process. So if we look at that on a graphic kind of perspective, there's our group 2s, group 1s, and essentially roughly the same within about 4 or 5 applications. You're looking at full-blown resistance across the field. And again, these are applications, and this is a very, very simplistic model here, where you're looking at doing all those applications back to back. If you intersperse those, the more times that you intersperse those, so let's say you're alternating between 2 different groups for their particular weed, you would push that back to the right-hand side of that graph by double what you see there. And if you're adding a 3rd group into that rotation to control that weed, then you push it back by 3 times, and so on and so forth. But as we go farther to the more rare the mutation, then we can move it way out to the right-hand side. And that blue one there, that's the 1 in 10 million to times a 1 in 100 million odds herbicides, and that's a combination of the both of those, and as a result you're getting much lower odds of finding that resistant individual. So why do we want to think about this? The progression of resistance in Canada is going on a linear fashion, and just like in the Olympics, we get third in the race to resistance in the world. The bigger concern though is weeds that are resistant to multiple groups. And so we can see that we've got a very quick rise in weeds that are resistant to multiple groups. So as far as two particular herbicide groups, and fewer concerns as we go farther down. And you would think that we wouldn't have a whole lot of those ones that are resistant to 5 and 6 groups. But if we look at wild oats, and from a historical perspective, we do have a situation in Manitoba where there is that population that's resistant to group 1, 2, 8, 14, and 15. And I omit 14 from that because it's really not particularly strong on wild oats in the first place. So it's a bit of a misnomer to include it in that group. But we forget one of our groups that was in use back 30 or 35 years ago, which is group 25, or Madivan. And we've got populations in Manitoba that are fairly widespread. They're resistant to that group as well. So it's not a big stretch for us to have those 5-way resistant populations out there. So this is the other concern that we have, is that populations in Saskatchewan are following that same trend as nationally. And given that extension, we can expect that by this year and this coming season, which will be the second year of resistance testing in our regular weed surveys across the province, we can expect that the results that come out of that in the next couple of years are probably going to indicate 80 to 90% of fields within the province will have at least one herbicide-resistant weed biotype. If we look at wild oats, they seem to be the ones that dominate the resistance concerns. And so with our group 1s, we've got a steady line upwards, so that about 70% of fields by now probably have resistant biotypes to group 1s. Group 2s really didn't get a lot of options on the market until about mid-2000s, and pretty limited prior to that. So that's why that curve starts a little bit further along. And so we're looking at 40% of populations that could have resistance of group 2s by then, and then the combo follows along just shortly behind the group 2 line. Where do we go with group 8s? We don't know, because they didn't really test group 8s in the last survey. So we really didn't get a good read on that. So we're not really sure where that sits. Some more developments in Western Canada out of that same survey from 14-15. We've got 15% of fields with group 1 resistant green foxtail, and that's 44% of the foxtail tested. And that's probably not increased a lot in the last 20 or 30 years. And I would suspect that that's by and large as a result of direct seeding. 21% of fields have group 2 resistant green foxtail. And that one's a bit different, because the group 1s are typically what we know is our standard way that we develop resistance, and that we get a single gene mutation, and that makes the plant completely resistant to that group. Whereas with the group 2 green foxtail, we're looking at metabolic resistance in those cases, and with that we get more cross resistance developing within the group and also between groups. So that's one that's a bit of a concern. We've got 6 broadleaf species that show group 2 resistance in the last survey. So we've got chickweed, cleavers, pigweed, redroot pig, or shepherd's purse, stinkweed, and wild mustard. And the pigweed, shepherd's purse, and stinkweed, this was the first time on the survey that they showed up as resistant biotypes. So we're still evolving resistance in the province on new weeds. Some of the survey, there was a survey conducted in 2017 on kochia, looking at glyphosate and other herbicides. 300 were collected from around the province. 40 were resistant to glyphosate, and that's glyphosate alone. 8% were resistant to dicamba, and then there were 10% that were resistant to both glyphosate and dicamba. And of course, most, if not all, kochia populations are resistant to group 2s now. 2018, that same survey took place in Manitoba, and they were finding 59% of kochia with glyphosate resistance. And we should be seeing a report out of Manitoba fairly shortly. And then this year, kochia survey took place in Saskatchewan, and we'll probably see the results of that here over the next year or two. So we're headed towards a wall, and so we need options to deal with that. And so we want to make sure that we're doing things to pump the brakes. When producers are surveyed with respect to what they're doing to manage weeds, you can see that herbicide shows up a lot here, which can be somewhat problematic, and depending on the way that you use them. So we want to make sure that we're using cultural methods as well as some of these things I'll be talking about today. And they also talk about crop rotation, so we can use different herbicides. So this means that we're getting on to our that will move on. So the problem is that we've got a limited number of pathways that we can use in a plant to control it, and the chemical manufacturers aren't holding out. They're still making investments in new herbicide technology, and we did hear that Bayer had found a new mode of action here just recently, but also keep in mind that that mode of action, we're probably looking at things like corn, soybeans, cotton, and maybe rice would be, and canola maybe, where they would insert the gene, because that was a non-selective thing, much like Liberty or glyphosate, and they would have to develop crops that were tolerant to that herbicide in order for it to be used in crops. Using that other group 1, so whether it's clethodim or prinoxidin, that are a little bit more robust, those are not a sustainable option in rotation. You want to hang on to those like a rare gem so that you have them available for when you need them, rather than use them on a more routine basis and build up resistance that way. Switching to a group 2 grass control herbicide is not long-term control for group 1 wild oats, and it's largely because our mutation rate is much higher with group 2s, and so that's essentially like jumping from the frying pan into the fire. And we do have our 3-way resistance showing up in kochia. And so we've got group 2 resistance in a multitude of weeds, and they're getting pretty close to kochia and the amount that's there. Just one thing to keep in mind is that once you have resistance, there's no going back. It remains resistant forever. There is no returning that population to a susceptible population after it's resistant. So what do we want to do? We want to grow a vigorous crop. We want to diversify our crop rotations. We want to pick herbicides in rotation, and this is particularly important for pulses. Pick the herbicide in the rotation where you have the fewest options, and then expand your selection of herbicide groups as you increase the number of options available for that particular crop in your rotation. So that's a strategy to use so you don't get yourself boxed into a corner and using the same groups over and over again. You want to be able to mix herbicides from different groups together that control the same weeds, and these have to be effective mixes. So you have to be very careful about advertising that you hear on the radio where they say they've got X number of groups that are in their particular herbicide, you need to be very careful to think about what each group is controlling. And I don't really want to pick on velocity because there's lots of them out there. But velocity is one that kind of stands out a little bit in that, yes, it's got 3 groups for controlling broadleaf weeds, but it still only has 1 group for controlling grasses. And so that's the thing you really have to kind of keep in mind with some of these things when you hear some of the advertising on the radio. We want to make sure that we can physically remove seeds from the field, and that could mean mechanical. So whether you're doing a little bit of tillage here and there, or whether you're doing harvest weed seed control, you want to rotate the forages every once in a while, and maybe an option is swapping land with a livestock producer nearby. You both get win-wins from that. He gets phosphorus back into his soil, and you get the weed control or removal of the weeds. If you suspect a patch out in your field, don't hesitate. Go out there and deal with it aggressively and make sure that it doesn't get spread around before you end up trying to manage it. And remember the no survivors rule. So if you've got a suspicious plant out there, don't wait until next year to deal with it. Go out and rogue the field and yank it out. We talked about forages and putting forages into the rotation. This is the kind of results we can see after a short-term perennial forage rotation, and that we see a dramatic drop in wild oats and Canada thistle and cleavers. Increases in dandelions, however. Generally, seed life in the soil is pretty short for things like kochia. Should be no reason for kochia to persist in a field because it only lasts as a seed for about 2 years. After the 3rd year, there's next to nothing left. People often overestimate the length of wild oats in the field. This is a study that comes from 1966, so we've known this for quite a while. And essentially this study, what they did here is that they had little mesh cages that they boxed the wild oat seeds in and buried them at specific depths in the soil, and would pull them out from time to time and see how many emerged. So essentially what you saw at a really shallow depth is that you had very little wild oat seed carrying over into the following year, so less than 10% of that seed. And as time went on, you saw a gradual reduction. Once you got that seed buried between 2 and 8 inches deep, that's when you had fairly dramatic carryover of that wild oat seed, and then deeper than that 8-inch depth, the viability dropped as well. So that sweet spot between 2 and 8 inches, that's essentially where wild oats goes into stasis. And if we can leave it there, not disturb it, that's fine. But the lack disturbance, not disturbing that is maybe not such an option. But the real key thing to kind of note here is that if we look at this curve, yes, it's fairly high the first year after seed shed, but it drops fairly dramatically, and out to year 7, you're looking at next to no wild oat seed persisting in that field. Competitive cropping practices. Try and make sure that you can increase your seeding rate, you get improved yield, and you also get reduced weed populations. And this is a visual example of that from Indian Head, where we cross-seeded some tame mustard and tame oats as weeds and looked at increasing our seeding rate and narrowing up our row spacings, and found that these pictures here take note that there are no herbicides being used in this plot. So we're getting very good weed suppression even without the presence of a herbicide. Herbicide layering, so that's kind of the topic that we're getting to here right now. Essentially, when we talk about mixing as a way to mitigate herbicide resistance, these don't need to necessarily be in the same tank load. They can be something you apply to the soil, and then you come in after the fact with your in-crop herbicide. And that's also having 2 modes of action in that field at the same time to mitigate resistance. And not only do you improve weed control, but you can get an improved improved return on that as well. And layering can be used to reduce multiple resistance in one weed or address several weeds prone to resistance to different groups. So what we'll do is we'll look at soil active products that are available in pulse crops, just as a quick overview here, and just a note of some of the timing references here. The PRE code will stand for pre-emergent surface, and that's following planting, and that requires rainfall to activate. The PPS is a pre-plant surface prior to planting, and that also requires, both of those surface applications will require rainfall to activate the products. And there are certain products that do require soil disturbance to activate them, so PPI is a pre-plant incorporated pattern. So just remember those codes as we go through the next few slides. So if we look at some of the products that we have available, I've got the product name on the left-hand side. I've got the active ingredients there in the second column, the crops that you can apply these to, those codes that I was talking about, and any sort of precautionary notes that come with that. So when you're looking at sulfentrazone or the products going under the name of authority, whether that be with or without the peroxysulfone component, one thing to kind of keep in mind there is soil organic matter in the right-hand column, and there's lots of soil limitations for that. You can only put it on soils between 1% and 6% organic matter. And then if it's a clay soil, that bottom number goes up to 1.5%. You don't want to put it on coarse soils that are primarily sand, because that'll mean that these things will move into the rooting zone and potentially cause more injury to the crop if that's a risk. And you want to keep it in soils that have less than 7.8 pH. The authority charge, that's essentially just authority with some AIM thrown in there to enhance the glyphosate burn-off. So not to worry too much about that. Avidex, essentially a product with a single weed, which is wild oats. The active ingredient triolate, and that's a group 8 there. I forgot to put the group number in there. Field P is the only pulse crop that is currently on the label. And this one requires a little bit of incorporation just because it is so volatile. And it can be as little as a heavy harrow in opposite directions to get this stuff integrated. And basically the idea is that you're knocking that granule down so that it lands and comes in contact with the soil surface rather than getting hung up on the straw that happens to be above that. So that's kind of the key thing for using Avidex, or the other trilate product is Fortress. Dual Magnum, S-metallochlor is the active ingredients, group 15. Essentially only dry bean, soybean, and lupins. That requires a fair amount of rain to activate, and so it is a pre-emergent surface, so you put it on after the seed goes in the ground. It can also be used as a pre-plant incorporated as well. In this case, if you don't get adequate rainfall, you can actually do a little bit of harrowing to try and integrate it and get it working again, but nothing's as good as a good rainfall to get that stuff working. Edge or ethylfluralin is in group 3, and products in the group 3 family are both volatile and they're broken down by sunlight. So that's why incorporation is very important with these products. The more disturbance you get, the better the activity you get out of them. And fall is definitely better for performance than application in the spring. And the reason for that is that your temperatures are going up in the spring, increasing the volatility, and your day lengths are longer in the spring, which is resulting in more breakdown via sunlight. So those are some of the little tricks to getting things working properly with the group 3s. we've got Fierce in chickpea, dry bean, lentil, and soybean. It's a pre-soil active product, requires rainfall to incorporate. Focus, very similar. Fierce has the same limitations as the Authority did earlier on, so the 1 to 6% organic matter. Focus has a 1 to 7% organic matter limitation. Heat Complete is a combination of heat and the active ingredient that's in Focus. And there was a situation a few years ago where lentil was being injured by that combination. And so what they've done with the Heat Complete is that they've reduced the rate of Focus and reduced the rate of heat in that combination so that it reduces the risk of injury to lentils in particular. And as a result, that means that you're getting suppression rather than what you might get for control with the normal rate of Focus for the weeds that are on that label. Not really thought of too much, but Imazethpur or Pursuit is the proprietary name on that one. If you put it on early post, you're going to get a pretty significant soil residue to control weeds with that one as well. Linuron in soybean and lupin only does have a pre-emergent surface application. Again, requires quite a bit of rain to activate. Metribuzin, similar, used in Eastern Canada as a pre-plant surface application or pre-emergent surface. Again, requires quite a bit of rainfall, and the rates are quite a bit higher in Eastern Canada for that type of use pattern. Here we only have a pre-plant incorporated mix with trifluralins for metribuzin, and that's only in conventional tillage because you have the requirement for a high level of disturbance, and you're looking at the liquid versions of trifluralin, which are more prone to hanging up on that stubble that's sitting on the ground. Permit is for use in dry beans, and that's a group 2. Has some soil residue, can be applied either post or pre-emergent surface. Tie down is a new combination of metolachlor, which was in dual, as well as metribuzin, and that's for soybeans only. And so surface applications there, you need to make sure that the soybeans are seeded fairly deep in that case to avoid problems with injury. Trifluralin we talked about earlier at the same time as the edge, and again, you have to kind of make sure that you get more disturbance there, and we've got a fair selection of crops available. Valterra is flumioxazin, and you saw that up in Fierce earlier as well. It's for use in soils less than 5% organic matter. You want to avoid heavy clays with that, or soils that are high porosity or high percent sand or gravel. And then Zidua is a relatively new product, first time out last year. Proxasulfone, again, similar to Focus, similar to Fierce, similar to Authority Supreme. So you're seeing that these same active ingredients cycling around through this chart as far as herbicide options. And so it sounds like there's a lot of products, but you're looking at a fairly limited number of groups and still have to use these judiciously in order to avoid resistance. What can we do with a combination of foliar and soil active type of use patterns? Soil active use patterns. And what kind of benefits can we see from them? You can see here when we're tank mixing these products, whether in 2-way or 3-way mixes here, some research done at the University of Saskatchewan in canola. We got better control of cleavers in this situation with the mixes than we did with the standalone products on their own. And we also saw lower dockage from cleavers contamination in the grain. And the other thing that was really nice is that we also saw improved yields out here on the right-hand side, and the three-way mix yielded significantly more than either the two-way mixes or the products on standalone. So we're seeing a yield benefit there as well. Similar in Cleavers Control and peas at the Rostern site, they did some work there as well. And they looked at the green bars here, each product used individually, and very few of those would meet the industry standard that's considered to be control. But when you combine them, both soil active and foliar applications, they found that you improve your cleavers management quite substantially in those situations. And here's similar results in the second year of that study. This isn't a new concept. Those with gray hair like myself will remember back into the 90s when Monsanto, when they owned Avidex, they had the Avidex yield challenge. And essentially what they were doing is they were trying to sort of stave off the introduction of those new products, those group ones that were coming out that were really good at controlling weeds, and by promoting the advantage of yield in their products. And so what they would do is promote that. And this was based on work that was done by Ken Kirkland out of the Scott Research Farm. And what we found is that when you use a pre-emergent herbicide versus foliar applications, and the later you make your foliar application, the less yield you get. You're getting economic advantage even of a pre-emergent, even to that early post-emergent application. And so if we look at the economic advantage of some of those things as well, so at minimum you're looking at about a $24 per acre yield advantage there. And if you're really late on your applications, you're gaining quite a bit of money per acre in yield. So for herbicide layering, herbicides can contribute even without controlling the weed. And so the example of that is Command and the canola charts there. Preferably, we want to make sure that each component of that multi-mode of action operation is able to control the weed as a standalone product. You want to make sure that you get ahead of the problem. Don't be complacent and wait until you already have problems with resistance. You want to get ahead of the curve and start doing this before you have any signs of resistance showing up. And folks from Europe would encourage you to do that. They have problems now with the weed called blackgrass, and they waited for they got on that herbicide treadmill, and they kept using herbicide after herbicide on a standalone basis to control this blackgrass weed. And now they're at a point where they have to apply 6 active ingredients in the same field to control or even just suppress blackgrass. And they're looking at $100 or $120 an acre for that cost just for suppression. Some of our challenges to integrated weed management, and have a chat with your dealer about that and all the granular fertilizers that they're encouraging you to spread on the soil surface. We've got some results from 1998. We understood that banding and side banding was the real sort of Cadillac as far as the way to apply fertilizer. Otherwise, if you're flinging fertilizer around, you're just fertilizing your weeds as much as you're fertilizing your crop. And there's those other negative aspects where you're losing some of it back to the atmosphere. So that's one of our challenges, is that the nitrification inhibitors have made it fashionable to spread granular fertilizer on the soil surface again. And also the heavy promotion of high-speed tillage implements. Now that people have bought them under wet conditions, they want to make sure that they get their money's worth out of them, so they use them during all kinds of different conditions. Commodity prices haven't necessarily been conducive to nice diverse rotations, and so that's a bit of a concern. And up until recently, we've had commodity associations competing amongst themselves for acres for their crop, and we're getting much better cooperation between commodity groups now. So in summary, integrated solutions need to be part and parcel with your control measures. You want to get ahead of the weeds, make sure that you reduce the weed populations before you get into the herbicide game. Some cultural methods are just as good as or better than herbicides, and use tank mixing and layering to reduce the odds of finding that resistant biotype. And essentially what you're doing there is you're trying to find one there that's resistant to both things or multiple things in that mix. So we'll jump right into herbicide carryover. And what is it? How does it happen? And what do we need to know going into this year? Herbicides break down in two primary ways. One is microbial activity and the other is chemical hydrolysis. And the animation there on the right-hand side is demonstrating chemical hydrolysis. Essentially, a water molecule comes in and splits that herbicide molecule in half and deactivates it. And microbial activity, by and far the most common breakdown pathway. Pretty much all herbicides of one kind or another will have some microbial breakdown component, and then they'll have hydrolysis added in there as well in a lot of cases. So you've got your microbe that comes along and it chews up your herbicide and uses it as food, essentially. And so the other thing that influences herbicide persistence is binding. The more polar your herbicide is, the more it will bind to soil. And what do I mean by polar? What that means is that the stronger the charges that are on those herbicide molecules, the more that they'll be attracted to the negative charges that are on the solid portion of your soil. And so these brown bits here would be considered the solid portions of your soil. And when you look at that close-up of your soil, you've got this layer of water that's around those solid bits, and then you've also got air in amongst all those solid bits as well. And you need all of those components for good breakdown. And if there's a couple of minor components we talked about earlier, which is photodegradation and volatilization, but they're fairly minor as far as breakdown goes. So if we zoom into what's going on there at that barrier between the solid and the liquid phase of the soil, let's assume that this is our, let's say it's one that's got lower binding, so it's something like a group 2 or group 4. And so what you'll find is you'll get fairly equal proportions of that herbicide on either bound to the solid portion of the soil or available in the soil water. This is more representative of something that's bound fairly strongly to soil. So things like your group 3s or glyphosate or bromoxynil will look more like that, where you've got fewer molecules out here and more stuck to this the solid portion. So what happens over time with microbial breakdown is that this is our little microbe buddy, and he comes along, and as he eats those components out of that soil water, more are released from the solid portion until you have all of your herbicide broken down and you've got a happy microbial population. One thing to keep in mind though is that there are some restrictions on that, is that when it starts to get cold, and that's why we kind of limit our time frame that we look at for moisture for herbicide breakdown. When it gets cold, you lose the ability to break down your herbicide. The microbes don't perform as quickly, the chemical reactions don't take place as fast, and once you get into frozen ground, all breakdown stops. And this is really nicely illustrated by some research that was done on biobeds by Dr. Cessna and Wolf and their partners here when they were looking at biobeds. And if we look at the 20-degree bar, which is in green, versus our 5-degree bar, which would be sort of the bottom limit of where we would look at for soil breakdown, you can see that in some cases you're going out 3, 4, 5 times longer to break that herbicide down as it would at optimum temperatures, which would be the 20 degrees. Breakdown in the early fall, you're probably looking in that 13-degree range, and even there for some products you're seeing that that's moving way out from that optimal breakdown point fairly quickly. The Ally is not as reliant on soil microbes for breakdown, so it doesn't change very much with respect to temperature because it's using primarily hydrolysis. But as a result of that, you are seeing a longer extension of the residual of that product out there, and it can be affected by soil pH as well. The other thing that impacts herbicide persistence is soil moisture. And when we get into a drought situation, that pushes more of these herbicide molecules onto the solid portion and leaves fewer areas for our little microbe friend. And when you've got really, really strong dry conditions, it's just about pushing all of those molecules onto that solid partition, and it can be a bit tougher to pull those back off again. So we're going to look at what's happened over the last 3 or 4 years of dry conditions. And then we'll look at what the rainfall was like last year and kind of think about what's going to happen here in 2020. So the dry conditions started in 2017, where we had a good chunk of the southern and western portion of the province were under pretty significant moisture reduction, and then the rest of the province was under a fairly moderate moisture reduction, which could also result in reduced herbicide breakdown. But those areas in red and dark orange there, those are areas where you're going to get fairly severe reductions in herbicide breakdown. What we do is note the time frame on when the rainfall is measured, and that's what I was talking about earlier, is that we only measure from the 1st of June to essentially the 1st of September. And what we try and do is make sure that we have the same number of weeks in there when we're comparing year on year, because we will get a bit of a flex back and forth from time to time. And so this in 2017 for carryover into 2018, we're looking at fairly problematic areas in the southwest here and sporadic issues out here in the rest of the province. If we look at what happened in 2018 for carryover into 2019, we had a little bit of a contraction of that really red area. I did add another extreme level here, and so we're seeing a few areas here where we've got very extreme dry areas for the breakdown of herbicides. And one thing to kind of keep in mind is that if we look at the combination of what happened in 2018 overlaid onto 2017 rainfall, there are also some areas in here where there was not enough rainfall to break down herbicides adequately over even a 2-year period. And so that will even present problems for us going forward. So here's what we're looking at for the rainfall from 2019, hoping to predict into 2020. And you can see here that we've still got some areas here on the west side of the province that are limiting in rainfall with respect to herbicide breakdown. And so those are areas to kind of be cautious about. But the other thing that we want to try and keep in mind is what was going on with those areas here where we had poor breakdown for the 2 years previous to 2019. And what that means is that for herbicides that have a residual restriction of more than a year, so if you apply it 1 year, you have to wait until not the year after to grow that crop. But 2 years or 3-year restriction. And the one that kind of stands out as an example of that is something like Authority that has a fairly long half-life, or even trifluralin for that matter. In those cases, we still have to be aware of these hotspots where there was very little breakdown in order to make sure that we're entirely safe. So you have to kind of keep those areas in mind moving forward. So how is this gonna impact our crops going into 2020? Well, there's still a relatively high risk of unexpected carryover in certain areas, especially in those areas west of Kindersley and down around Maple Creek. For other areas of the province, it's pretty adequate for those products that have a single season recropping restriction. Consult with the manufacturer with respect to those 2018-17 seasons as far as those ones that have longer carryover timelines than the single year. So that's essentially the discussion, and we'll hand it back to Sherry Lynn.
Great, thank you, Clark, for all that information. That was a lot of stuff and a lot of great stuff. Just a reminder, that was good. Just a reminder, if anybody has any questions and they haven't typed them in, please put them into the question section. It's one of the bottom tabs there, and then they will come through and I can ask them to Clark. We did get some questions about CCA credits, and just a reminder that Andrea will send out an email as a follow-up, at which time you can post your CCA number. So there was a couple comments before I get into questions. There was a couple comments that did come through. I really didn't have questions, but just comments letting us know that Volterra is now registered for spring application before lentils. So that is something new that has come through. Also, there was some experience with some residual products just suggesting that if recommendations aren't followed in terms of incorporation properly, like the more than a heavy harrow, that product warranty may not be accessible. So making sure that people follow those recommendations. And maybe Clark, you want to comment on, you know, products where there is more than a heavy harrow recommended, what can be expected in terms of weed control, the reduction in weed control with that, and avoidance of warranty.
Yeah, and I suspect that that's probably with those things like Avidex or Edge or trifluralin, where you're looking at the liquid products where they bind to crop residue quite strongly. And so in those cases there, you need to be in a conventional tillage system in order to use those things effectively. You can still use the granules in a conventional tillage system as well, but when you're in that conventional tillage system, you need much more aggressive incorporation in order to make those things work and make sure that they don't leave the soil surface. When working in a min-till type of or zero-till type of system with those products where they're in their granular form, in those cases, the stubble that you have that's standing there helps create a bit of a microenvironment that helps to minimize some of the volatility of those products. And by what you're essentially doing with that harrow is you're shaking that material down to the soil surface to make sure that you're getting contact with that soil. And preferably even in the fall, what you're looking at is getting it to the soil surface before you get through that freeze-thaw cycle. And that freeze-thaw cycle, you'll do one pass with the harrow in the fall. The freeze-thaw cycle will break down those granules, and then we go through with another harrow in the spring in order to make sure that you get it well incorporated. You're moving that stuff around and you're blending it around a little bit with that second harrow application in the spring before you seed. Am I still with you?
Sorry, I had muted myself. So any comment on the range of control that can be expected if they're not fully incorporated?
Yes, what we find, and Sherilyn, we have to thank some of the grad work that was done at the U of S on this by some of the folks that were there when I was working for the U of S. They what they did is they looked at various levels of disturbance for incorporating edge and control of kochia. And what they found is that the more disturbance you had, the better control of kochia you got. And essentially, if you reduce your amount of disturbance with something like edge, you end up, you'll lose your broadleaf control first. Then you'll lose your cool season grass control, so things like volunteer cereals or wild oats. And then you'll start to lose your green foxtail if you just leave it on a bare surface with no protection at all.
Okay, good information. So another question sort of related to those type of products, if using the liquid formulation of Avid on fields with heavy crop residue, is it recommended to heavy hair before or after application, or will rainfall alone be enough to keep it from getting tied up on the residue?
Because of because of the polarity of Avidex, it's more inclined to bind to crop residues, and so that's why it's very difficult to use the liquid form of that in a min-till or zero-till system, because there's just too much of that residue at the soil surface, and essentially it all gets bound up, and very little of that will run off into the soil to be able to allow that to be used properly.
Okay, thank you. In regards to seeding rates in lentils, small greens as well as reds, they've always seeded around a bushel an acre. What is the recommendation now, and what factors would influence that?
Well, there's a bit of a tug and pull between seeding rates, between us weed folks and our disease counterparts. That there's the back and forth type of tug, in that the weedy folks will say, well, you can increase your seeding rates even in lentils to get a more dense canopy that will suppress weeds and it'll close in quicker. But the downside of that is it also sets up an environment where, especially if you've got a fairly heavy rainfall season, where you could be increasing your suitability for disease development. So it's a bit of a, for lack of a better term, it's a bit of a crapshoot sometimes to figure out where that fits. I know that Steve Shirtliff did some work looking at lentil seeding rates, and he found that he reduced his weed population significantly by pretty much doubling the seeding. It went from about 130 plants per square meter up to 230 plants per square meter, and got quite an improvement in control.
Thanks. I think just to add to that, I do believe, coming out of Steve's work too, the kind of ending recommendation was maybe to go up to 100, consider 180, but it's best to evaluate on your farm and still make sure you're, like you mentioned, Clark, managing the disease side of things with the heavier crop canopy.
Yep, you bet. Yeah, that's a good compromise. Yep.
Yeah. Just as I'm going through the questions, there was a request to show the slide again that has the definitions of the pre's, the PPS, and the PPIs. So if you can put that one up on the screen, Clark, as we go through some more questions, that would be awesome. Thank you.
Okay, sure.
So another question is, are there any wild oats that are resistant to group 3?
That's an interesting question, and there's a bit of a caveat to that to my answer in that there was one circumstance that has been recorded of resistance to group 3, and that was recorded in Oregon to curb. Now, what we do here is that we call curb a group 15. And so there's some confusion as to what group that actually sits in. So that's kind of the caveat to that part of the discussion. So really, if it's a group 15, then it's not resistant to group 3. There are wild oats that have developed resistance to glyphosate. But if we look at the group 3s overall, they're fairly robust with respect to resistance, regardless of what the weed is, and I'm not sure why they're as robust as they are. So I would suspect that we haven't seen that yet, but we never want to say never.
Right. Thank you. The terminology of metabolic resistance is kind of confusing. How does one know if a plant has metabolic resistance?
Okay, I'll do a little bit of a background behind that question. So normally when we think of resistance in, let's say, group 1, for argument's sake, it's what produces that is a single mutation on that enzyme that is the target site for the herbicide, and that means that the herbicide won't fit into that spot anymore. With metabolic resistance, that target site remains the same, essentially. So it's still a susceptible target site, but what happens is that there's multiple gene changes around that can do several different things. It can mean that the plant is able to break down the herbicide faster. It can mean that it limits its ability to translocate that herbicide through the plant. It can mean that maybe you have to have 2 changes to a target site in order to make it resistant without really damaging the mechanism of the plant. And the other is that maybe what you're doing is you're moving a whole mechanism from an outer membrane of the plant to the inner membrane of the plant that allows the movement of that herbicide that enters from the outside to get shunted right into what's essentially the garbage can of the cell, which is called the vacuole. And by doing that, it doesn't allow the herbicide to get into the functioning components of the cells of the plant, and there imparts resistance that way. But typically these are multi-gene changes that accumulate over time. And often what we'll find with metabolic resistance is that you'll get a buildup of resistance, and the resistance that you get is not a really robust resistance. So you may start with it's resistant to the 1x rate, but you can still control it with the 2x rate. Then if you move to that 2x rate, you'll start selecting for individuals that are resistant to that rate, and it just kind of keeps gradually ratcheting up over time. Whereas with that single mutation that disrupts that enzyme that herbicide attacks, that's resistant to all rates, all in one shot. And so that's the real key difference between a metabolic or non-target site type of resistance versus a target site type. Does that make sense?
Oh, thanks, Clark. Is there a difference of resistance risk of soil-applied herbicides versus foliar herbicides? And does the resistance apply to both products equally? If it's resistant to the foliar application, does the soil-applied product still is it still resistant to those soil applied products?
What we may find with soil active products is that for them to be effective, they have to be, by definition, somewhat residual. And what we find is that products that are residual and control weeds for an extended period of time are selecting more for those resistant biotypes versus a product that you apply it to the foliage of the plant that you're trying to control, and then after that it has no soil activity. And so essentially it allows any of those weeds that germinate after that to continue to grow and kind of outcompete the resistant biotypes. So that's the real key difference between a soil applied product and a foliar. We do have some foliars that will have a soil residue, and so you're still getting some of that selection going on after that foliar application. And so in those cases, they're going to act much the same as that soil residual product.
Okay, thank you. The next question, is there any thoughts on the weed destructor mounted on a combine to reduce weed seed viability? Is there some research out there being done, and is that information available?
I think we've got a topic for another webinar.
Sounds good.
Because I have a whole presentation on that. A good source of information on that is out of Australia, where they've done a lot of work on harvest weed seed management, whether it be the destructor or whether it be something very simpler like chaff lining or tram lining, where they drop it behind the wheels of the combine, and then do controlled traffic farming over the top of that. There's lots of work there. There's a website called Weed Smart that's a very, very good extension website and they do a lot of they produce a lot of information on harvest weed seed control. The Australian Herbicide Resistance Initiative is another source of that information. And the fellow that's really sort of the key leader in a lot of the extension material around harvest weed seed control is Peter Newman. And you can find him on Twitter talking about these things all the time.
Awesome, thank you. I think that's a great idea. Maybe that's the next webinar. Mm-hmm. And that's another question regarding sort of mechanical options. Is there anything that can be done to increase herbicide breakdown? For example, we had more of a dry summer, but then a wet fall, rains at the end of August. Is there anything we can do in the fall to reduce the herbicide carryover? And what kind of risk are we expecting when we have a fairly dry summer and then the rains in the fall? So I guess that's a two-part question.
Yeah. It all kind of goes back to the conditions that we need for herbicide breakdown. There's nothing that we can really add to the soil that will enhance breakdown, given that, if we use this past fall as an example, many areas of the prairies got rain and even snow in a lot of cases right sort of in the early fall time frame, and then temperatures stayed really cool from that point onward. Essentially, at the point when that moisture came and cooled things off so much, you would get very, very little soil breakdown in those situations. And that's why it's so very important for that time frame that we have for our maps. That's why we're so focused on that. If for whatever reason we have a long open fall, we don't get any really particularly cool weather, and we can kind of maintain a relatively decent soil temperature, going into, let's say, mid-October, we might be able to use some of those, extend that time frame for looking at later season moisture and what the benefit of that might be in breakdown. But you really have to evaluate what the temperature profile is in that fall period when you may get that moisture. So if you've had a largely dry season and then all of a sudden you get a whole bunch of rainfall right at the end of August, that's really not going to do much for herbicide breakdown, unless for whatever reason we have really warm, balmy temperatures up until Christmas.
So would tillage at all, working those layers, impact the amount of carryover in a case like that too, like a fall tillage? I
suspect that probably what would happen with tillage is that you're going to dry that layer out more. If you, in some cases, what you can do with tillage is you can dilute that layer where you've got the herbicide of concern. The flip side of that is that if your next crop is very, very sensitive to that herbicide, you may have just dragged that herbicide down into the rooting zone of that crop and created more risk for that crop rather than less. So I wouldn't say that tillage would really contribute all that much to breakdown.
Okay, thank you. On a similar note then, talking about kind of seeding sensitive crops, there was a Sencor or Metribuzin in-crop question regarding seeding depth and or rain events that could affect large green lentils. Do you have some comments on that?
Yes. With Sencor, Metribuzin, we have to be very careful about seeding depth, especially in soils that have low organic matter and are fairly coarse soils or sandy soils. And the reason for that is that if you get a fairly heavy rainfall, that can push down into that rooting zone of the lentil if it's seeded at less than an inch or inch and a half, and cause pretty significant injury to the lentils, essentially turns them almost white. So that's the real concern under those particular soil conditions. If you did the same thing in a heavy clay soil, you're probably not going to see the same risk of injury. With that soil incorporation use pattern with trifluralin, that's the other sort of flip side to that use pattern, is that now you're working it down into that rooting zone, and yes, you're diluting it a little bit, but you're still putting that lentil plant within that risk area of that herbicide when you're seeding particularly less than an inch.
Thank you. So I have one more question, and then that will be the end of it. The question is that some suppliers are recommending a surfactant for residual products. What are your thoughts on this, if there's any need in the absence of emerged weeds? The claim is that there's better spread within the soil.
Yeah, that's a bit of an interesting question, and I know I've heard that as well, is that the supposedly the adjuvant is allowing, it's sort of breaking the surface tension of the soil is the concept. If you get adequate rainfall for incorporation without the adjuvant and you have added the adjuvant, does that increase your risk of that stuff moving too far? Because sometimes with these soil active products, physical separation is your selection process, and so there could be a risk of moving that material down too far in the soil profile, especially if you had a fairly heavy rainfall after the fact and you had a little bit on the lighter side for soil.
Thank you. Well, I think that ends our questions and our webinar time for today. Thank you again, Clark, for sharing all your knowledge and answering all those questions that we did ask. And a big thank you to Andrea as well for organizing the session today. And an even bigger thank you to all those that attended and joined us today and asked those many questions. So we, just as a final note, we are working on our next webinar that will focus on the maximum residue limits and market implications with Greg Barkley from Pulse Canada. So watch for that one. The date has not been set yet, but we will be announcing it soon. And thanks again for joining us today, and I hope everyone has a great afternoon. Thank you.